Hello friends, welcome to this lecture of COA. In this lecture, I am going to discuss about the architecture of microprocessor in details. It is a very important topic when you are appearing for exam, viva or interview. So in my last lecture, I was discussing about the configuration of 8085 microprocessor, which includes 40 pin IC where the ground is placed at pin number 20, where the power supply is provided at pin 40, and we can categorize these 40 pin into six kinds, and this include address pin, data pin, control and status pin, frequency and supply pin, single instruction transfer pin, and externally initiated pin. Let us check how these 6 kinds of the pins are basically placed on the architecture of microprocessor. So the microprocessor that we are considering in our entire lecture series is basically 8085 microprocessor. The associated microprocessor would be the 8086, which have some of the extensions. You can say some of the new instructions that has been included in 8085 that led to the formation of 8086 microprocessor. But that is a talk of our further lectures. But in the entire lecture series, we will try to focus on 8085 microprocessor. So let us check what is the architecture of 8085 microprocessor. So this is our microprocessor 8085. Do remember you can say the abbreviation that we have used for the microprocessor: mu, that is micro, and P, that is processor. So in microprocessor, the first category of pin is address pin, and that is basically that is represented from A0 to A15. So that is address pin. Then we have data pin. Then we have control and status pin. We have frequency and supply pin. Then we have single data transfer pin. It is single data or single instruction transfer pin we have. Then So these are externally initiated pin. We have also other kinds of the externally initiated pin inside the microprocessor 8085. These are basically hold pin, HLDA, then ready pin, reset in, then reset out, and finally we have so this is reset in, this is reset out, and this is all about. So this is basically the architecture of microprocessor 8085. So all these are very important pins that we have to consider. Let us now get into the details of these pins. Starting with address pin, which is basically consists of 16 pins, that is from A0 to A15. So when we talk about the address pin, what we have to remember under the address pin, that address pin is basically unidirectional. That is, it is understood that through the address pin we can transmit our data in only one direction, not in the both directions. So it is basically the unidirectional pin. Second thing we have to remember, that address pin is basically it is constituted of 16 pins. So an address basically consumes 16 bit of memory inside the main memory. So it is very important, it is a 16 pin. The second pin that we have to consider is basically the data pin. So when we compare the address pin with the data pin, we come to know that data pin basically bidirectional pin. And when we say bidirectional, it simply means that data is able to transmit in both the direction, forward and the backward. And we can simply understand it that whenever the data flows, it is always has a capability to flow in the data pin basically provides this capability to the data to be moved in both the direction. So that is the bidirectional pin. And the number of the pins that basically constitute the data pin is 8. Then control and status pin, when we say it has a capability to control the working basic working of the microprocessor, and it is able to tell about what is the status of input output output of data inside the computer. We will talk about more about in the coming lecture of microprocessor, that what is the significance of all these pins. So let us discuss in short what is S0 and S1. S0 and S1 pin, S0 and S1 pin basically they tell about the current machine instruction processed by CPU. So very important thing, that S0 S1 pin simply tell about the current machine instruction processed by CPU. So machine instruction basically number of machine instruction constitute interrupt instruction, that we will discuss in our coming lecture of the microprocessor. So this is very important thing, S0 and S1. Let us now move on to I0 and M. It basically tells about transfer of data either through input IO device or main memory. IO device and main memory. When I0 is 0, it simply means that the inversion, that is an inverter over the I0 make it 1. It means that when I0 has the zero voltage apply over it, when the I0 has a status of 0, it simply means that at that time input output device is able to transfer the data, and when M has 1 over 1 as a bit, it simply implies that data is now transferring to the main memory but not the input output device. So it is very understood that at one time only 1 bit can occur on any of the device. Where it is 0 at I0, it simply means the transfer of data takes place through this one, and when M is equal to 1, it simply means that data transfer takes place through M. So next thing is read. So read, as the name implies, that it tells about the status of read of data. When it is 0, it simply implies the bar over the read simply make it 1. That means read operation takes place. And when we say write operation, that means when 0 is over the write, it simply implies that write operation is taking place over the microprocessor 8085. Fine. So the next component is ALE, and what basically ALE tells about, let us understand that. So ALE basically implies address latch enable. It simply means that ALE when has 1, it simply means that ALE act as a address pin. ALE act as the address pin, that is A0, A15 come into existence. When ALE has 0 bit, it simply is 0 unit over it. It simply means that ALE acts as a data pin, and it is basically replaced by D0 and D7. Let us talk about all other 3 categories of the pins in our next lecture.